doesn't matter what level of math you actually get to or what level of math that you're working with. If you need to graph a line, you can always do this. Just always. You can always get a chart, make a chart of values, and graph it. It's totally fine. Not the most efficient way, but you know what? It works. Sometimes the most efficient way is just the way that works for you. Hi, I'm Sarah. I've been a math and science teacher for 20 years, and I enjoy making math engaging and fun for everybody. If you want tutoring, micro tutoring, Cameo, click the link and do the stuff. So when you're graphing, right, what a line graph is showing is it's showing all the possible points that meet that relationship. If we've got y equals like 1/3 x plus 2. So what we're doing here is y equals 1/3 x plus 2. We've got this relationship between x and y, right? So we've got 1/3 x plus 2. So what this means is to get my y value, I'm going to take 1/3 of my x value and I'm going to add 2 to it. So I can think of this, I can always, I'm going to get a thicker marker to show up. So now when I'm doing this, I'm going to plug in my value for x. I'm going to do times 1/3, which means divide by 3, and then I'm going to add 2. When I'm choosing values for x, I'm going to make this easy on myself. So if I think about, okay, I'm multiplying by 1/3, which means I'm dividing by 3, I'm going to make sure that my x values are all divisible by 3. It's going to make life a lot easier. So maybe I'll choose 3. Maybe I'll choose 6. And then I want to make sure that I do some negatives. So I'm going to do -3. Okay, maybe I do -3 and -6. Okay, so I'm going to do all of this, and then I'm going to plug these in. Okay, and I'm just substituting these values for x and then solving for y. So I've got 3 times 1/3, which is 1, plus 2, which is 3. I have 6 times 1/3, which is 2, plus 2 is 4. I have -3 times 1/3, which is -1, plus 2 is 1. And then I have -6 times 1/3, which is -2, plus 2, which is 0. So now I've got all these relationships that I can put onto my graph, because my graph is going to show all the in-between relationships. Because it's a line. It's not going to change directions. Because this is a linear equation, this is going to be a straight line going all the way. Okay? So it's going to be a straight line going across, and we are going to plot our points. I've got, when x is 3, y is 3. So x is 3, y is 3. Boom, right there. When x is 6, y is 4. X is 6, y is 4. Boom. X is -3, y is 1. X is -6, y is 0. So look at that. Look at that beautiful line going across. There is my beautiful line going right across there. So we can always plot points, and we can always graph the line that way. Okay? Now what we can also do, the other way that we can do this is when you look at this equation, right? When you look at this, it's called a linear equation because it's just a straight line. So linear equations, we've got this plus 2. We've got, it's going to be a y-intercept of +2. Which if you look, the y-intercept is where the y value is where the line crosses the y-axis. That's at +2. Boop, boop. And then the slope is 1/3. So the slope is the relationship between vertical change and horizontal change, kind of like steps. So if we look at this, between these 2 points, I'm going to go up 1 and over 3. Okay? And that relationship, that angle stays the same the whole way. So even if I zoomed way, way, way in on a really microscopic level, it's still going to go burp, 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 up 1/3, up 1/3, right? Up 1 pixel over 3 pixels, right? Up 1 micrometer over 3 micrometers, okay? So this stair step, this slope is going to stay the same no matter what, no matter how far we go along the line, either direction. That's MathedUp.